Hey guys, Dr. Brown here. In a previous video, we had integrated secant x tangent x over secant x plus secant squared x, and we ended up with minus natural log of cosine x plus 1 plus c. Now, in this video, we're going to take the derivative of that answer and see if we, in fact, come back up with what we started with. So let's get after it. You know, if you're in calculus 2, that the integral of du over u is in fact a natural log. If you're in calculus 1, you just know if you take the derivative of a natural log, you end up with the derivative of the function over the function. So let's go with that thought. We'll assume we're in calculus 1 here. Now, before I start, if I have some sign out here, I like to put it where it goes to simplify. For me, it simplifies what's going on. So I know this can be written that the function itself is the natural log of what? Cosine x plus 1 to the negative 1. So when I take the natural log of that, that's where the negative comes from, okay? So that's my function that I'm taking the derivative of, and I'm going to end up with the derivative of cosine x plus 1 to the negative 1 over cosine x plus 1 to the negative 1. That's my function. That's the derivative of the function. So let's take the derivative of this numerator. Okay, that would equal, bring the negative down, negative 1 times cosine x plus 1 to the negative 2. Remember the chain rule. So that was my outside function. Now I've got to take the derivative of the inside. Matter of fact, I'll draw it like this. We had that function to the negative 1. That's what we had. So we bring the negative 1 down. Not 1 negative, it's negative 1. Negative 1 times that outside function to the negative 2. Now we've got to take the derivative of the inside function. And that is how, in my mind, I think about the chain rule and a general power rule, how to use them. All right, so we've taken the derivative of the outside function. Now the derivative of what's on the inside, derivative of cosine, is minus sine x. And derivative of that constant is 0. Now that over the function itself, cosine x plus 1 to a negative 1. Now, so I'm just going to remove the 1. I have a negative this. Negative times negative is a positive. So I have a positive sine x. And now I have a negative 2 minus a negative 1. Be careful there. It's minus 2 minus what's on the bottom, minus 1. So that's negative 2 plus 1, which is negative 1. So all this dividing out, I end up with cosine x plus 1 to the negative 1. So that now it becomes that to the 1 since I move it to the denominator. Okay, so sine x over cosine x plus 1. Well, so far, that's not this. What to do now? Well, let me multiply this by 1 over cosine x over 1 over cosine x. So that gives me the tangent term. That's where my thinking is going here. So I end up with tangent x over cosine x over cosine x plus 1 over cosine x. Now let me move up to the top here. So I have tangent x over cosine x over cosine x is 1 plus 1 over cosine is secant x. Well, we're getting close, aren't we? Now, to get that, hey, let me multiply this by secant x over secant x. So that gives me secant x tangent x over, if I distribute this, secant x times 1 is secant x plus secant x times secant x is secant squared x. So that, from the earlier integration, tells me that answer was correct. I would encourage you, if you have the time, I know and when you're in school, you're pushed for time. I get it. I'm 67. I have plenty of time. But if you can, work the integration problem. If you're in calculus 2, then do the derivative to see if, well, one, you practice your derivative so you don't lose that skill. But also you can confirm before you turn in that homework that the answer you've gotten earlier is in fact correct. Okay? All right, why are we doing this? We say it every video, and I truly mean this. Together, we're trying to build a better tomorrow. The world's a little mixed up right now. I think we need to show a little more compassion to our neighbor. We need to be, my mother used to say, if you say something, you can't unsay it. If you can't say something nice, don't say anything, so that together we can build a better tomorrow. I'm trying to help us do that through math. Okay, that's all for now. Hug a kid and be nice to one another, and we'll talk to you next time. Thanks.